About 13.75 billion years ago, our universe as we know it today was created. At that epochal moment, shortly after its birth, primordial light began shooting across the cosmos, spreading evenly throughout the early universe. Simultaneously with the eruption of light, the universe itself also expanded exponentially. However, the universe's dizzying inflation slowed dramatically after the initial burst, known as the inflationary epoch. Despite this slowdown, the rate of expansion then began to steadily increase again. This inexorable increase is due to the mysterious influence of dark energy, the amount of which increases as space itself expands. Essentially, it can be said that the cosmos has grown at an ever-increasing rate since its creation, driven by a repulsive force that continues to defy our understanding. Physicists and mathematicians have devoted hundreds of years to the in-depth study of the nature of the universe, tenaciously seeking to solve the mysteries it holds, from the fundamental forces to the composition of matter. But there are some scientists who dare to step forward into the unknown, pushing beyond accepted models and actively considering what lies beyond the confines of our universe. Is it really possible that there is something beyond the existence of our universe? We're talking about other universes, entirely new worlds whose existence we can only tentatively imagine. It could very well be so. This video explores 5 fascinating and radical theories about what this something more might be, and what current evidence science has found to support these various theories. The notion of outside the universe is very complicated and requires a more precise definition of the term universe. A common formulation that does more justice to the crux of the matter is the term observable universe, for which the speed of light plays a key role. Because light travels at a finite speed, we can only see things when the light they emit or reflect reaches us. Consequently, we will never be able to observe further than the maximum distance light has traveled in the entire time the universe has existed, which is 13.75 billion years. Leading cosmologists estimate that the oldest photons we can observe have traveled a distance of 45 to 47 billion light-years since the Big Bang, due to the expansion of space. This means that our observable universe is approximately 93 billion light-years across, plus or minus a few light-years. These approximately 93 billion light-years contain every single particle, star, planet, nebula, and black hole ever recorded by a telescope, and everything we might theoretically be able to observe in the future. But the observable universe contains only the light that has had material time to reach us. This also means that our observable universe is constantly growing larger. However, this observable universe is also finite. The limited amount of space and matter we can see is also called the Hubble volume, a tribute to the famous telescope that has given us the most distant views of the universe to date. We will never be able to see beyond this limit with conventional methods, so it's essentially the only universe we'll ever interact with. However, we know with a probability bordering on scientific certainty that there is much more universe beyond that edge, an unobservable space. Astronomers believe that space, invisible to us, could be infinite, with matter, energy, galaxies, and stars distributed more or less exactly as in the observable universe. This uniformity suggests a homogeneous expansion. Beyond the Hubble volume, we will not only find more planets in general, but also other planets very similar to our Earth. The infinite nature of the universe implies an infinite number of combinations. If we go far enough according to this theory, we'll find another solar system with an identical Earth in every way, where this morning you ate cereal instead of eggs for breakfast. It's another world where you skipped breakfast due to an unexpected commitment, and even another world where you woke up in the morning and then robbed a bank. In fact, some cosmologists believe that if you travel far enough beyond the boundaries of the observable universe, you'll find another Hubble volume completely identical to ours, a perfect replica. And in those other Hubble volumes, there's another version of you out there, a cosmic double that reflects every possible action you could take. This may seem unlikely, but the infinity of the universe is an extremely difficult concept to imagine because it simply surpasses human imagination. To clarify this phenomenon, according to the theory of relativity, objects that are close together cannot move toward each other faster than the speed of light. However, there is no such law that constrains objects that are extremely distant, since the space between them can expand at any speed. In short, it is not the objects that move faster than the speed of light, but the space-time between the objects itself that expands, causing them to fly away from each other at astonishing speeds. Ultimately, this means that we could reach the edge of the observable universe only if we developed a method of transportation that allowed us either to travel faster than the speed of light, a theory most physicists believe impossible, or to transcend space-time via wormholes or warp drive, which most physicists still consider highly unlikely. Dark flow. In 2008, astronomers discovered something very strange that they had not expected. Galaxy clusters were all flowing in the same direction, as if pulled by a single source, at immense speeds, over 2 million miles per hour. New observations conducted in 2010 confirmed the existence of this anomalous phenomenon, known as dark flow. Scientists discovered the phenomenon by studying some of the largest structures in the cosmos, clusters of giant galaxies. These clusters are collections containing about 1,000 galaxies and very hot X-ray emitting gas. By observing the interaction of X-rays with the cosmic microwave radiation, CMB, the thermal residue left over from the Big Bang, scientists can study the motion of galaxy clusters. X-rays scatter photons in the CMB and shift the temperature in an effect known as the Sunyaev-Zeldovich kinematic effect. This effect had not previously been observed as a consequence of galaxy clusters, but was first noticed by a research team led by Alexander Koslinsky, an astrophysicist at NASA's Goddard Space Flight Center. The team examined about 700 clusters up to 6 billion light-years away, halfway across the known universe. They compared these clusters with the map of the CMB taken by NASA's Wilkinson Microwave Anisotropy Probe, WMIP satellite. The motion of the clusters defies all predictions about the distribution of mass in the universe after the Big Bang, suggesting an external force. One possible cause is the existence of massive structures outside the Hubble volume that exert a gravitational influence. Scientists are almost certain that the source of this attraction lies outside our known universe. This would mean that the structure of the infinite universe is not uniform beyond our view. As for the structures themselves, they could be literally anything, from gigantic accumulations of matter and energy on almost unimaginable scales to bizarre fault lines conducting gravitational forces from other universes. Infinite bubbles. Talking about things outside the Hubble volume can be misleading because it is still the same universe of which we cannot see only a part. The same physical laws and constants apply. In another version of the story, the accelerated expansion of the universe after the Big Bang led to the formation of bubbles in the fabric of space. Each bubble stopped expanding with the rest of space and formed its own isolated universe, each with its own unique physical laws and constants. In this scenario, known as the bubble multiverse, space is infinite and each bubble is infinite by itself, based on the concept that a single infinity can contain an infinite number of infinities. Even if you could somehow break through the edge of a bubble, the space between the bubbles would still expand faster than any of your movements, so you'd never reach the next bubble, no matter how fast you moved. Black holes, a theory proposed by physicist Lee Smolin, known as the fertile universe theory, states that every black hole in our universe within itself triggers the creation of a new universe. Each universe will have slightly different physical laws than the previous universe. A mutation. Smolin thus suggests a kind of natural selection for universes, since the physical laws and conditions that lead to the frequent formation of black holes are also the reason for the formation and proliferation of other universes, while universes that do not form black holes die out. This theory has since been debunked by Smolin himself and others. Infinite parallel universes. There are countless theories about parallel universes, but the most valid theory today involves a further development of the ideas of string theory. These are so-called membranes or branes, oscillating in other spatial dimensions. It would be beyond the scope of this video to go into too much detail about string or membrane theory, but the core of the theory is that the rippling membranes between worlds in the 11th dimension are entirely different universes, and when the ripples collide, a new universe is formed. Wave effects help explain the observed distribution of matter in our universe. One of the strangest elements of the theory is the notion that all the gravity we experience in our universe actually enters this universe from another universe in another dimension, which explains why gravity here appears so weak compared to the other fundamental forces. What do you think? Are there other unknown worlds outside our universe? Does infinity exist? And if so, how infinite is it really? Parallel universes, matter deformation, string theory, membranes, and black holes. Do you think this is just a hoax, or is there something real? Leave your opinion in the comments.